turning point. The story of how a failed experiment became one of the most famous materials of the 20th century. A material that changed kitchens, manufacturing, the cookware market, and the way people expected ordinary surfaces to behave. But before Teflon ended up on frying pans, before an egg could slide across a hot surface, before the word non-stick became a promise printed on cookware, it was just a strange mistake inside a steel cylinder. Most people know Teflon from the kitchen. A pan gets hot, food touches the surface, and instead of sticking hard to the metal, it lets go. Today, that feels normal, almost boring. But earlier, cooking was often a small fight. Food burned, eggs tore apart, pancakes left pieces behind. A pan had to be soaked, scraped, scrubbed. And when breakfast went wrong, the problem did not end with the ruined food. The problem continued in the sink. Teflon changed that feeling. But the most interesting part is this. No one was trying to invent a miracle frying pan. No one was standing in a kitchen thinking, how do we stop food from clinging to metal? The story began somewhere completely different. In 1938, inside a DuPont laboratory, with a chemist named Roy Plunkett. He was not working with cookware, not with kitchens, not with a household product. He was working with gases, refrigerants, industrial chemistry, a world of cylinders, valves, pressure, and careful measurement. Then one cylinder stopped behaving normally. It was supposed to release gas. Plunkett opened the valve, but nothing came out. The cylinder seemed empty. Only there was one problem. It was still heavy. That detail kept the experiment from being written off as a simple failure. If the gas had not come out, but the cylinder was not empty, then something had happened inside. When the cylinder was finally opened, they found not gas, not liquid, not the expected result, but a strange white substance, waxy, powdery, unplanned. To most people, it would have looked like failure, a ruined cylinder, a lost day, a chemical mistake. But Plunkett did not throw the result away. He began testing it, and that is where the real story of Teflon begins. Because the turning point was not the mistake itself. Mistakes happen every day. The turning point was that someone stopped in front of the mistake and asked, "What is this?" Scientific discoveries rarely arrive beautifully. They do not always look like moments of genius. Sometimes they look like an annoying failure. An instrument gives the wrong reading. A sample disappears. A reaction goes the wrong way. A container does not work. And the first feeling is not wonder. It is frustration. That is how it began for Roy Plunkett. He and his team were working with tetrafluoroethylene. It was a gas connected to research into new refrigerants. The task was practical and technical. Get the substance, test it, repeat the process, move forward. But that morning, the process stopped. No gas came out. The valve opened, and nothing. In a laboratory, that usually means one thing. Something went wrong. They could have replaced the cylinder, made a note, started again. But the weight of the cylinder said something else. Something remained inside. And that simple physical detail turned failure into a mystery. The team opened the cylinder. Inside was a white material. The gas that was supposed to come out had changed inside the closed space. Its molecules had joined into long chains. That was PTFE. Later, DuPont would give it a name that became far more famous, Teflon. But at that moment, there was no brand yet, no frying pan, no advertising, no consumer market. There was only a strange white material on a laboratory bench, and it behaved unusually. It did not break down like ordinary substances. It did not fear high heat in the way they expected. It did not react with aggressive chemicals in the way other materials did. That mattered. But it was not immediately clear. Because a rare property is not yet a product. A material can be amazing and still have no obvious use. And this is where the Teflon story becomes more interesting, because it did not come out of the cylinder as a finished answer. It came out as a new question. What do we do with it? Where can it be used? Can it be made again? And who even needs a material this strange? An ordinary customer could not walk into a store and ask for a white chemical powder. The kitchen was not part of the story yet. The home was not part of the story yet. First, Teflon had to prove its value in another world, a harsher world, a more secret world, and one much farther from breakfast. Before Teflon became a consumer product, it had to prove that it was worth something, not in theory, in real systems, where a material either survives or everything breaks. During the Manhattan Project, engineers faced more than physics. They had to solve equipment problems. The systems had to handle dangerous and aggressive substances. Ordinary materials could break down. Seals could fail. Valves could become weak points. Pipes, surfaces, connections. Everything that touched the process had to be reliable. And here, Teflon became useful. Not as a beautiful idea, as a material that could serve where others failed. It earned trust, and gradually, it became clear where a material like this could matter, where ordinary gaskets were eaten away by chemistry, where valves and pipes had to withstand aggressive substances, where equipment could not be replaced after every contact with a dangerous environment. In military and industrial fields, Teflon became an almost ideal candidate. It could be used for seals, insulation, coatings, parts that had to withstand heat, pressure, and chemical attack. It did not look like a consumer product, but for engineers, that was even more important. It was a material that could protect a system from the inside. Engineers saw that it was not just white powder from a failed cylinder. It was a substance that could be used where a mistake was expensive. So Teflon made its first journey, from accident to working material. But it was not mass market yet. Most people still knew nothing about it. An ordinary family did not buy Teflon, did not ask for it, did not see it. It existed in the world of engineers, secret tasks, and industrial solutions. To become a major consumer product, Teflon had to enter a completely different world: the home, the stove, an ordinary kitchen problem. And that transition began with an unexpected point of view, not from a laboratory report, not from an industrial plan, but from a simple household idea. The kitchen turn came later, and it did not begin with a big corporate plan. Not with an advertising campaign, not with a meeting about the future of cookware. It began with a simple idea. If this material helps in complicated technical problems, could it help at home? In the 1950s, French engineer Marc Gregoire was working with Teflon in practical applications. By then, the material had already proven its value beyond the laboratory. But it was still not an object for an ordinary kitchen. It belonged to the world of engineers, equipment, industrial problems. And then the household turn came from the place where it was least expected, from his wife, Colette. She saw in the material not an industrial rarity, but a possible solution to a kitchen problem. She suggested trying it on a frying pan. And that sounded almost strange. A material used in serious technical tasks, suddenly placed next to eggs, pancakes, and ordinary breakfast. But that was the break. They tried it. The pan heated up. Food touched the surface. And instead of the usual fight, it came away more easily. Not as an idea on paper, not as a chemical property in a report, but as a result that could be seen with the eyes. At that moment, Teflon became understandable for the first time not to an engineer, but to an ordinary person, not through a formula, through a simple feeling. Food no longer held on to the pan. And here, the laboratory material began turning into a consumer product. The problem was not explaining chemistry to people. The problem was making the benefit visible. A buyer did not need to understand P, T, F, E, did not need to know the molecular structure, did not need to hear long chemical names. They needed to see one motion. Food touches the pan and comes away cleanly. That was the perfect demonstration. No complicated words, no instructions, no technical lecture. An ordinary person understood the change immediately, not because they understood the material, because the result was visible at once. At that moment, Teflon stopped being a strange substance from a laboratory. It started becoming a product. But making a product is not enough. It still has to be shown in a way that makes people want to try it themselves. Now Teflon did not need to be explained. It needed to be shown, because a pan with a new coating was the kind of product that was better seen once than described for a long time. Take the pan, heat it, put food on it, try to cook, and you will understand. That was the strength of Tefal. People did not need to believe in complex chemistry. They needed to see a simple scene. The egg does not tear. The pancake releases more easily. The pan stays cleaner. Washing no longer feels like punishment after cooking. For a person in the kitchen, this was not a scientific discovery. It was relief. That is why the demonstration worked so strongly. Teflon was turning from an industrial material into a personal experience. Not, this is a new coating, but why can't my old pan do that? This is where the market begins. The first customers did not only receive new cookware, they received a story that was easy to repeat. Try this pan. Almost nothing clings to it. Cooking is easier. Washing is faster. Things like that travel well from home to home, especially when the subject is the kitchen. Because a kitchen is not a lonely laboratory, it is a place of conversations. Neighbors, relatives, friends, homemakers, families. People see a new thing in someone's home, ask about it, try it, and begin to want one too. Word of mouth worked almost as strongly as advertising, because the promise was too easy to understand. Less fighting with food, less irritation, less time at the sink. Then advertising picked up that promise. Tefal began turning a simple demonstration into the image of a new kitchen. The pan no longer looked like an ordinary piece of metal. It looked like an object from a more convenient future. Modern, practical, almost smart. And when a product gets that image, it stops being only useful. It becomes desirable. In 1956, Tefal was created. The name joined two parts of the idea, Teflon and aluminum. Tefal. This was no longer a laboratory substance, no longer a secret industrial application, no longer a material for engineers. It was a pan you could buy, put on the stove, and feel the difference immediately. Then the story began to accelerate. Demonstrations, sales, advertising, kitchens, conversations between customers, expansion into new markets. And gradually the old habit began to break. For years, people had accepted the pattern. Food cooks, food sticks, then you scrub the pan. Tefal offered another scenario. Food cooks, food releases, you spend less effort. And once a person sees the easier way, the old way stops feeling normal and starts feeling like an annoying problem. That is how Teflon became mass market. Not because people fell in love with chemistry, because they were allowed to try convenience, and they did not want to go back. After that, Teflon was no longer just a material, and no longer just a frying pan. It became part of a new expectation. If earlier a person bought cookware and thought about size, weight, price, and durability, now there was another question. How easy is it to live with? That was a shift. Buyers began expecting more from ordinary objects, not only to perform a function, but to remove irritation, save time, make a daily action slightly easier. This is where Teflon became more than a kitchen coating. It became a symbol of a new consumer logic. A good product should not only work, it should make life softer, quieter, more convenient. It should hide complexity so the person never has to see it. And Teflon fit that era perfectly. After frying pans, the non-stick idea began to spread wider. It moved beyond one kitchen and one pan. Coatings began appearing on other cookware, on pots, baking molds, irons, and different household surfaces where people were promised the same thing again. Less effort, less sticking, less irritation in daily life. And this changed the market. Because when convenience becomes the standard, it becomes harder to sell as a miracle. But its absence becomes a problem. The old pan now seemed not simply ordinary. It seemed inconvenient, heavy, outdated. And this is one of the strongest effects of inventions. They do not always make people dream about the future. Sometimes they simply make the past harder to tolerate. Teflon did exactly that. It changed not only the object, it changed the comparison in the buyer's mind. But this story has another side. When a product lasts a long time, eventually the question becomes different. What happens to it after? An ordinary old pan can be imagined as metal, but a Teflon pan is no longer just metal. It is metal with a coating that does not want to disappear easily, and that creates an unpleasant irony. What made Teflon useful inside the product? Stability, durability, chemical resistance, after use could become a problem. A pan like that is harder to treat as ordinary scrap. It cannot simply be burned safely anywhere, and if it ends up in a landfill, the core character of the material does not disappear. It continues resisting the world around it. And here, the story of Teflon stops being only a story about a convenient kitchen. It becomes a story about the price of convenience, about what happens when a material is made so well that it outlives the product itself.